The silicon floor of the global economy isn't just shifting, it has been completely replaced by a proprietary architecture that most of the world didn't see coming until the invoice arrived. We are currently witnessing the most aggressive consolidation of computational power in human history, centered not around a nation-state, but a single point of failure: the H100 GPU. This isn't a hardware story. It's a narrative about the commodification of intelligence itself. While the public focuses on the viral interface of LLMs, the real war is being fought at the substrate level, where Nvidia has effectively locked the gates to the future. By controlling the CUDA ecosystem, they've moved beyond being a mere vendor to becoming the central bank of compute. If you want to build the future, you don't just buy their chips. You pay a perpetual tax to their software stack, creating a feedback loop where the more you scale, the deeper you're integrated into a monopoly that is mathematically designed to be inescapable. To understand the magnitude of this capture, one must look past the stock tickers and into the thermal dynamics of modern data centers. We've entered an era where intelligence as a service is the only export that matters, and Nvidia has secured a 90% plus market share in the accelerators that power it. This isn't the Microsoft Windows monopoly of the 90s. It's more akin to a single company owning all the world's refined oil and the engines that burn it simultaneously. The paradox lies in the compute divide, a widening chasm between the 5 hyperscalers who can afford the $40,000 per unit entry fee and the rest of the sovereign world. We are transitioning from a geopolitical order based on geography to one based on flops, floating point operations per second. In this new reality, the sovereignty of a nation is directly proportional to its local GPU clusters, making Jensen Huang the most influential architect of the 21st century's strategic infrastructure. Nvidia's dominance was not an overnight conquest, but a 20-year exercise in high-stakes, anticipatory engineering. While Intel remained tethered to the legacy of general-purpose CPU dominance and Moore's law began to hit a thermal ceiling, Nvidia took a massive architectural gamble on parallel processing. In 2006, they released CUDA, Compute Unified Device Architecture, a software layer that allowed developers to treat a graphics card like a massive, multi-threaded supercomputer. At the time, Wall Street viewed this as a costly distraction from the gaming market, yet it was the birth of a semantic node that would eventually strangulate the competition. By seeding universities and research labs with free hardware and a robust compiler, Nvidia ensured that a generation of computer scientists learned to speak one language: CUDA. This created an immense switching cost, moated by millions of lines of proprietary code that cannot be easily ported to rival hardware like AMD's ROCm or Intel's Gaudi. This strategic long game transformed the GPU from a toy for rendering pixels into the foundational engine of the generative era. The transition from the von Neumann architecture, where the CPU and memory are separate, to the massive throughput of the tensor core represents a fundamental pivot in how humanity processes information. Nvidia didn't just build a better mousetrap. They built the only factory capable of producing the precision tools required for deep learning at scale. By the time the AlexNet moment arrived in 2012, proving that neural networks could outperform traditional algorithms, the infrastructure was already proprietary. This wasn't a lucky break. It was the culmination of a decade spent perfecting the vertical integration of the hardware-software stack. Today, competitors aren't just trying to beat a chip. They are trying to dismantle a 2-decade-old cultural and technical standard that has become the default operating system for artificial intelligence. The economics of the Nvidia monopoly are hidden within the interconnect strategy. Most analysts focus on the chip, but the real moat is NVLink, a high-speed proprietary protocol that allows thousands of GPUs to talk to each other as if they were a single, massive brain. While the industry standard PCIe 5.0 struggles with a bandwidth of 128 gigabytes per second, NVLink 4.0 delivers a staggering 900 gigabytes per second. This creates a cluster-scale lockdown. If you buy an Nvidia chip, you must buy Nvidia's Mellanox networking gear and Nvidia's InfiniBand switches to achieve peak performance. The result is an asymmetric return on equity that is unprecedented in the semiconductor space. In 2024, Nvidia's data center margins hovered near 80%, a figure usually reserved for high-end software companies, not hardware manufacturers. They are selling a $3,000 piece of silicon for $40,000, and the demand is so inelastic that customers are signing multi-year take-or-pay contracts just to secure a spot in the queue. Looking deeper into the dark supply chain, Nvidia has weaponized its capital to secure the entire output of TSMC's CoWoS, chip-on-wafer-on-substrate, packaging capacity. By prepaying billions to the world's only high-end foundry, they have effectively denied their rivals the advanced packaging necessary to compete. It's a classic cornered market play. Even if a competitor like Grok or Cerebras designs a superior AI architecture, they cannot manufacture it at the scale required because Nvidia owns the assembly line. Furthermore, the introduction of the Blackwell B200 platform introduces a 25 times reduction in energy consumption per token, a metric that makes legacy hardware obsolete overnight. This forced obsolescence cycle keeps the hyperscalers, AWS, Azure, and Google, in a state of perpetual capital expenditure, effectively funneling their cloud margins directly back into Nvidia's coffers to maintain their own competitive standing in the AI arms race. The final pillar of this monopoly is sovereign AI. Nvidia is currently bypassing traditional retail and enterprise channels to sign direct treaties with nation-states. From India's multi-billion-dollar GPU sovereign fund to France's Mistral project, Nvidia is positioning itself as the utility provider for national intelligence. They are no longer just selling chips. They are deploying AI factories as turnkey solutions. Each of these factories utilizes the Hopper architecture, which includes dedicated transformer engines designed specifically to accelerate the math behind large language models. By embedding these specific hardware accelerators, Nvidia ensures that any breakthrough in AI research is mathematically optimized for their silicon. This isn't just a market lead. It's a recursive optimization loop where the software evolves to fit the hardware, which in turn justifies the purchase of more hardware, creating a self-sustaining cycle of dominance that traditional antitrust frameworks are ill-equipped to handle. We are now entering the inference hegemony phase. For years, Nvidia's critics argued that while they owned the training market, building the AI, they would lose the inference market, running the AI. This was based on the assumption that once a model is trained, it could run on cheaper, less powerful chips. However, Nvidia executed a brilliant pivot by integrating TensorRT-LLM, a software library that optimizes inference specifically for their architecture. They didn't wait for the market to commoditize. They shifted the goalposts by making the inference-to-training ratio a moot point. By vertically integrating their NIMs, NVIDIA Inference Microservices, they have turned their hardware into a programmable cloud environment. They are essentially cannibalizing their own customers' business models, offering the software layers that allow developers to deploy AI models with a single click, provided they stay within the NVIDIA ecosystem. The ultimate game changer, however, is the shift from component vendor to systems integrator. With the launch of the DGX SuperPod, NVIDIA isn't selling you a chip. They are selling you a $100 million supercomputer in a box. This move up the value chain is designed to disintermediate the traditional server manufacturers like Dell and HP. By controlling the entire rack, the cooling, the networking, the power delivery, and the silicon, Nvidia dictates the total cost of ownership, TCO, for the entire AI industry. They have moved the competition from a price-per-chip battle to a value-per-watt war, where their integrated systems are so much more efficient that it becomes fiscally irresponsible for a CFO to choose a cheaper, non-integrated competitor. This systemic capture ensures that even as chip prices eventually face downward pressure, Nvidia's grip on the infrastructure layer remains absolute. The rise of Nvidia offers a definitive lesson in the architecture of power. In the digital age, the entity that controls the most efficient path for data flow eventually controls the data itself. We often mistake technology companies for being in the business of innovation, but Nvidia is in the business of computational real estate. They have built the digital highways, the toll booths, and the fuel stations of the next industrial revolution. The takeaway for any high-level strategist is that true market dominance isn't achieved through better marketing, but through structural inevitability, creating a system where the cost of leaving is higher than the cost of staying, regardless of the price. As we move toward an era of agentic AI and autonomous robotics, the Nvidia tax will become a standard line item in every national and corporate budget. The question is no longer whether they have a monopoly, but whether the world can afford to build an alternative before the Silicon Curtain fully descends.